So I've been working on water things for a while now. I've been trying to come up with a better way to make some more interesting swirly motion on my water surfaces. And one thing I wanted to try was to use some sort of animated noise texture instead of just a single static noise texture, something that evolves over time and kind of has like some interesting swirly shapes or whatever. And I've been playing around in Houdini for a while, and I've came up with this setup that I wanted to share. It uses pop particles to allow me to kind of like design the motion of the particles that I want, the way they move and how they interact and stuff to get some really interesting motion. And then it exports it out just to a texture. So I wanted to make a video showing how it's all set up and how it works. A few things that I wanted out of this though was I wanted to be able to loop seamlessly. I wanted it to be able to be tileable, so I can just tile the same frame of the flipbook over a surface many, many times, and be like seamlessly tileable without any weird UV artifacts, and also not have to have a huge, huge texture and lots of frames in order for it to look like okay. So uh, this is the texture that I have, and you can see that there's some nice swirling motion in there. Um, and then if we come over to Unreal, um, this is the texture in Unreal. You can see that it tiles really nicely, and if we change around this UV scale, you can scale it up and down, and we can see that we're getting some pretty nice swirly flowing motion. And it loops and it tiles and it's great. And it's a single 2048 texture, 64 frames of animation. And just before we get started, I just want to share this one link that kind of talks about how if you have a 3D volume texture or a flipbook and you try and tile it, you get these like UV seams. And it explains how to solve that. It's very interesting. I tried to implement this kind of solution in the way that my texture is exported out of Houdini. So it kind of works automatically, but you do have to do a little bit of extra work on when you're sampling the texture, the noise texture, just to make it so that it uses the data properly. So yeah, it's not too complicated. It took a little bit of figuring for me. I'm still kind of new to Houdini, but I want to try and explain this in a way that's very, very beginner friendly and not like overcomplicated and just straightforward and easy, because a lot of times I see Houdini tutorials and they just confuse me because they go over things that are assumed to already be known by beginners, but oftentimes it's still kind of like information that, yeah. Anyways, so I have a new Houdini project, and first thing we're going to do, actually I'm going to put this up on my other screen just so I can reference it. But so we have a new Houdini file, new project saved. What we're just going to do is make a grid, default size, 5 by 5. And we're going to jump into it and change its rows and columns from 10 to 10 to 256, 256, because that's what we want the size of a texture to be. We're going to leave it at size 10 by 10 because that's just what we want. And then we're going to use this grid into a pop network. And what we're going to do here is, this is what we're going to use to simulate our particles. So if we jump in here, and then we get rid of this guide, you can see that we're already getting some particles spawning on that quad that we made, but they're not doing anything. And we can add motion by adding some nodes in here. One that I like is the pop force node, just because you can add in some swirly stuff. So we just increase the amplitude, increase the swirl size a little bit, and then if we look at this, we're already getting some like nice swirly shapes. Can make the swirl size a little bit bigger. And now all of a sudden we have this swirly motion. And then we can add a pop drag. This is kind of really up to you of what kind of motion you want, but just get something simple going on. Now we have a drag force that kind of slows it down and starts clumping it a little bit. And we're going to write a little bit of Vex code. In this node here, we have a pre-solve input, and we can go pop wrangle and just kind of make this particle system loop inside of this square bound so that if a particle goes over here, it will just be teleported to the other side. And the Vex code for that isn't terribly complicated. I'm just going to copy and paste it from my other project. But what we're doing is we're setting the y position to 0, so it is entirely flat. And then we are making a bound size variable, which is going to be 5, because our quad was 10 by 10, so 5 units from the center in each direction. And then it's just saying if the x position is less than -5, so it's over here, teleport it to this side, and same for up and down, all 4 sides. So now if we run our particle system, you can see that it stays inside that square really nicely. So that is our particle system already. And if we go to visualize this, and then we're going to add a file cache to just export this out to disk real quick. Add your file cache and hit save to disk, and then save, and let this run really quickly. It should go relatively fast. Don't have too many particles here yet, but we're just going to save it to disk just so that it's a little bit faster to play back, because now we can play this back in real time. We already have some really cool swooshy motion. So next, after that, we'll notice that there's a tiny little bit of height variation in these particles. That's just because we are setting the height to 0 pre-solve, but after it solves each step, there still might be a height variation. So if we add another attribute wrangle here, we can just clamp the position. V at p dot y is equal to 0 to just guarantee that that's snapped to 0. And now we have a perfectly flat plane. And then what we're going to do is we're going to copy and paste this particle system 8 times around this centerpiece, just so that when we bake out the texture, we have a little bit more information around the edges that we can like blur with, and just so it's not at black right at the edge, because it'll give us a weird artifact. So in order to do that, we're just going to take a transform node and move it to the left 5, move to left 10, and then we're going to copy and paste this and have this at 10. And then, so we have the one on our left, we have the one in our center, and we have the one on our right. And then if we just merge all 3 of those together, we have all 3 of them. And then we're going to do the same thing to take this copy of 3, and we're going to move them up or down 10, and we're going to move it up 10, and we're going to merge that as well. So now we have our 9 particle systems all together. And we're really only going to care about the one in the middle, but yeah, we're going to sample a little bit outside of that, so that's why we need to do that here. And then we're just going to name this null, and we're going to go out particles tiled. So yeah, those are our particles. And if we middle mouse click this, we can see all the different attributes that our particles have. The one that we want to really export out, I mean, the 2 that we really want to export out are going to be density and velocity. And I just like storing that in color here just because it makes the particles cooler to look at, really. So if we go attribute wrangle, we can just set the vector attribute CD is equal to the vector attribute of a velocity. And now we have a visualization of the velocity, and it's nice and looped and looking good. There's a little bit of a seam there, but I think that will disappear once we're all done. So now we have our tiled particles. Let's just make a little bit more space here. So we create our grid. We spawn some particles on it and shoot them around. Save that disk, and then we just copy and paste this so it's tiled. Set the color to the velocity, and now we have our final output. So now that we have that, what we're going to do is we're going to rasterize these attributes to a velocity, or to a VDB, and then we're going to take a slice of it, and then we're going to transfer the data from each point on that slice to our final texture output. And so, let's see. First, we're going to kind of simplify how many particles we're working with, because we don't really care about all the ones like over here. We just care about the ones in the center and kind of within a range around it. So if we take our grid and we run it through a bound node, we can get a bounding box around it, and we can add some padding. So we just set a padding of 2 all the way around it. So now we get a box that's slightly bigger than the area that we care about. And then we want to, what I'm going to do is I'm going to go object merge, just for organization's sake, and I'm going to grab the data that's here, and I'm going to copy it over here. So we can just drag this into object 1, and it would be the same thing as taking this node and going like this, but I don't like that wire there, so I'm just going to object merge it, and it's the exact same thing. So we're going to take these particles and we're going to group them based on this bounding box. So all the particles that are now inside of this box, everything that's inside of this box is going to get set to a group. We're going to change group to points. And then we're going to say keep in bounding regions enable, and then bounding object. So you can see now the points inside the box have been colored orange. And then we're going to go delete, and we're going to delete everything, delete non-selected in this group. So it's going to delete all the points that aren't in this group. Group, delete non-selected points. There we go. So now we have a smaller subset of points, and just makes the next step a little bit faster. So that's why we do that. And so what we're going to do is we're going to run this through an attribute rasterize, volume rasterize attributes node. And what that's going to do is it's going to take all this data and store it in a volume. And then we're going to do a volume slice on it so we can visualize that. We're going to change this to XZ plane, and we are going to, in our volume rasterize attributes, we're going to rasterize CD, and there's our color volume. And yeah, so now if we run this through, we can see our velocity is changing. And if we go to the volume rasterize attributes node, we can change some information about here. And how this works is it's finding every point inside of a voxel grid that it creates inside this volume. And it's taking the average velocity of all the points. So it finds all the points in the voxel right here, adds up their velocity and gets the average there and stores that value in that voxel. And so we can change the voxel size, and that kind of reduces the resolution. We can lower the resolution too to get a much sharper image at the cost of performance. We can play with the particle scale too to determine how much influence each particle has over each voxel. So that kind of gives us more fine detail. And just a case of finding something that looks good here. And once we have this to our volume slice, we can then you can see that we middle mouse click here. Our volume has 133 voxels in the X and Y. But the texture that we want to export is going to be 256 by 256. And so we're going to end up undersampling or oversampling the volume because each point in the texture isn't going to correspond to a unique voxel here. So we want to find a good voxel size that's at least 256. And so we can play with this number until we get something that's at least 256. So that's good. And so we take this slice and we're just going to copy our attribute transfer. We're going to transfer the color attribute from the volume slice to our grid. And now we have our original grid. We'll turn off specular light. We have our original grid with looping tileable noise. And if we run this through a file cache, again, just so we can save it. This one might take a little bit longer, but I just like to file cache a million things. You can see that at the beginning it's super under-resolved, but as we go on, we get a nicer motion. So yeah, that's our velocity. But there's another type of noise that we might like, which is density. And we can get a density instead of just a velocity vector out pretty easily. So if we come back to our particles, we can just add a attribute wrangle. We just add a new float attribute that's called D for density, and just set it to 1. So every particle now has a value of 1. And if we rasterize those particles, the D value, we can come down to attribute rules and hit the little plus sign and say for the D attribute, instead of taking the average, we want to accumulate it. So if there is 10 particles in a single voxel, that voxel is going to have a density of 10 instead of taking the value, the density value, and averaging it. And then if we grab the volume slice of this and then remap this, we can see the regions that have higher density and they kind of swirl around, and That can be useful too for making a nice little grayscale map. Get a nice noise swirly look there. And again, we can change the rasterize attributes here. We should also really be spawning more particles, and we'll do that. I'll show you how to do that later at the end, just because we're using fewer particles, so it doesn't go super slow to process. But yeah, we can get a density out that way too, and it gives us a really cool look. And so we could transfer that also to the texture that we have, and we could cache that out as well, right? But for now, let's look at this noise, this velocity noise. And so the last thing that we need to do is we need to be able to export this to a texture, and we can do that with the labs maps baker node. And it wants a low resolution geometry, a high resolution geometry, and cage geometry. We don't need all of those, but this volume slice that we exported is actually going to, what we're going to do is we're going to take this and we're going to add normals to it, because we need normals in order to project data. It's just what it wants, and we're going to stick this in the high-res geometry. And then for our low-res geometry, we're going to grab the same thing, but we're going to attribute delete. We're going to delete the color off of it, because we are going to bake the color back. We don't want color on it if we're going to bake the color from this one. But the reason we do this is so it's baked into UV space. So if we go UV texture, now we have UVs on this volume slice, this quad texture that we have. And so once we have those UVs, we can plug them in here, and we can come to our maps baker, and we can say our resolution is going to be 256 by 256, and we want just the color, and if we hit, just checking make sure we are only rendering at the current frame. If we hit render, we should have a texture in our render. Yeah, so there's our first noise texture coming out. And what we can do is we can render out a frame range of these, right? We can go from 64, delete channels, we can go from 64, oopsies, I took a screenshot, go from 64 to 128 and render out a 64 frame image sequence of this noise. So that's what we're going to do. This is going to take a moment. I will probably cut this out because I don't know how long this is going to take. Or we speed through it. Ooh, I made a mistake. So in order for us to export this out, we need to add a underscore $F4. which means that it's going to append the frame number at the end of each image. And then one last thing before we do this actually is we want to actually remap this velocity. If we look at the geometry spreadsheet, we can see that the velocity is between a range, like the maximum, our value is 0.5, the minimum is minus 0.6, 7 and minus 7, and 0.6 to minus 0.6. We can't store negative values in our texture export, so we're going to do a tiny bit of math to remap it into a nicer range. Attribute wrangle. And it's not too complicated. We're just going to take the vector value, vector attribute color, and we're going to say fit it from a range of -2 to 2 and remap it to the 0 to 1 range. And so now our lowest value can be 0 and our highest can be 1. And when we read this back in our shader, we just have to unmap it back to its original range. And also when we are here, we could do like an attribute blur if we wanted to soften the noise too, which can be useful. So another thing that we can do here, which is kind of cool, is we can blur the texture too to make it a little bit softer. Just by using attribute blur and then choose new parameters CD, and then we can change these values, right? And we can make it softer and do whatever we want here. But yeah, so here's our maps baker, and we are going to make sure we have our $F4. So we have a frame. Oh, it didn't like that. Add our underscore $F4. And then let's bake this out. All of our frames exported. We can go to the image context and create a new image network and go inside of it. And then we go over to our composite view. What we're going to do is we're going to load in all of our frames and mosaic them together into a flipbook that we can then just export. So that's pretty simple. We just grab a file node and then we find the file sequence, image sequence that we just exported, which is this one, 64 to 128. And due to the way that Houdini works, I guess, it knows that we're loading in frame 64 to start, so it doesn't actually show anything until frame 64. It's saying there's no data. So you could like time shift that away, but I'm lazy, and I just move this to frame 64 and everything works. Or the frame that your flipbook is starting on. Yeah, so we have that, and then we just go mosaic. And then we say images per line 8, because we have 8 by 8 frames. Max images per frame, 64. And we visualize this, and now we have all of our frames. And yeah, then we just add a ROP file output, and then we can save this to whatever we want. I like saving it as a PNG. We don't need the frame number. And then we just go velocity noise. And then hit render current frame and hit render. And now we have our flipbooked velocity noise. Cool. So that's the easy, straightforward explanation, but we did actually skip a step just for ease of understanding of how this works. And part of the thing that we need to do is if we just take that into Unreal, we're going to have these tiling artifacts. So we haven't actually fixed that yet. And the way that we do it is kind of weird. But essentially, what we do is we, instead of transferring this color, let's go back to our scene view. Instead of transferring this color from the slice right to our grid, we actually we capture outside of this a slight bit, like 2 pixels on every side as a padding, and then we scale that back down to 256 texture. So while our texture is still 256 pixels, we're losing 2 pixels of data on each edge that has repeat. And he explains it here really, really well. But essentially, this green line is the same line as this green line. And so we have this duplicated pixels on each side. And the way that I was solving that is I actually just grab this grid and transform it. And oh, I should be ghosting this. Actually, I should be ghosting the original grid. So we have our original grid there. Which, for some reason, okay, no. So we have our original grid shown there. And then we have our transform. Make sure this is 0, 0, 0. And it's all zeroed out, right? So we have our grid right on top of that. But if we increase this, you can see that we get a little bit extra padding. And so I found the scale that works best for this. It is 1.01589, and that was just from scrolling around the values. And what that does is it extends these 2 pixels past our original size, and adds a 2 pixel border around everything, which is exactly what we want. So if we attribute transfer onto that instead, we get this shrinking effect, but when we sample it, we extend it back, and that fixes those UV seams. So if we then just let's change our viewing back to flat wire shaded, and we visualize this, and we get rid of the template. Resimulate this, and then rebake every frame, and then re-mosaic it. We should have a tileable texture. So for the last, I think that's everything. And yeah, so if you want to export the density instead, you can just pull this file cache into the exporting nodes, right? And we can use this density instead. But I'm going to resimulate everything here and just kind of firstly increase the amount of particles that we're spawning. So we go to the birth here, and then gonna increase the impulse count like 5,000, and maybe turn this off, and turn this to 2500. And that should give us more particles so that we have more data to fill up that volume that we're rasterizing. We're getting some pretty good swirly motion already. But let's just increase this amplitude by a bunch just so we can see something cool going on. And then maybe, yeah, there's a bunch of different force nodes that you can change here. There's like one that's really cool, that's pop fluid. And it kind of like groups everything together in like a nice watery kind of way. Oops. So if we ignore that pop force and just fluid surface it, you kind of get this like uniform, particles try and stay the same distance away from each other, which is really cool. And it gives like a nice watery, clumpy feeling. But yeah, so now we have more particles. We have this swirly motion. So let's go back to this and save to disk. Caching the particles usually is pretty quick. I don't know why we're doing 256 frames here, actually. This should only really go up to like 128 because that's all we care about. So let that finish. And then if we visualize the velocities here, it's a lot of particles. Actually, one trick that I do like to do is instead of sampling this right at the edges, like since this grid is copied 9 times around, the particles that actually spawn right on this edge are also going to be, like if they're the quad that's up here too is also going to spawn right at that edge. And so we get a little bit of oversampling. So one thing that you can do for that, oops, is you can transform this and scale this down a tiny, tiny, tiny bit, like just ever so slightly, so that we just don't get that overlap, just like that. Just there's a tiny bit of space, and then we only use that for the actual spawning of the particles. So let's save that to disk one more time. And then when we come over here, we reload these particles, and we're gonna export density this time. So we're gonna assign density of 1, we're gonna rasterize, and we're gonna grab a slice. And that's what we're getting as an output. We don't really like that because it's in the wrong range. And if we like look at, we can only visualize colors from 0 to 1, right? And so if we look at these density, the density goes up to 304. So we need to remap that from a 0 to 304 range to a 0 to 1 range. And we can do it here just by going like 300. And now we have a nice smoother gradient. Boop. Yeah. There's a little bit of sampling artifacts right there. So I think I made the quad a tiny bit too small. But let's change the rasterizing size since we have new particles. Since we have more particles. And just kind of like playing with this until I find something that looks like a nicer texture. So that looks pretty good. And then we're going to file cache this. And then if I double click, or if I, Control click, Alt click. I can add a new node there, and I can do it like that, so I can go like this. And then this is our frame export. We start at frame 64 just so we have the simulation already figured out. And actually, one more step that we forgot is making it loop. And the way that we do that is by right after the rasterize and before we take the slice, I'm going to cancel this, we can drop in a labs make loop node. We can just slot that in there. And since it's what we want to loop is the VDB, the volume, we can leave this at volume or VDB. We can change the start frame to 64 by deleting that channel and going to 64. And now we just have a looping VDB, just like that. So we save this and let this go, and then we can visualize it once more. 45-minute video, oops. I'm not very quick at explaining things. We still have a few spots I'm noticing of like really, really bright pixels. And I wonder if that's, it's because the density is now up to like 600. Oops. So let's cancel this again. And change this to, I just go 750. There, now we have a nicer gradient. Save to disk in background. Let me visualize this. Looks cool already. So now that this is all cached out, we have all of these frames. Ooh, look at that motion. That's really cool. And you can actually see where it loops. If we export out a flipbook here, which should be real fast, and then make the starting frame 64, you can see that this is our final result, and it loops perfectly. And it looks very smoky and swirly and looks real good. So let's actually render this out to disk. We're just going to append density at the end of it, just because. And then what is this name evaluating to? Testing, color, frame. So I guess let's name this density. Does that work? Yeah, there's our density texture. So we bake that out. So I export this out, and I'm not happy with how it looks. It's there's not enough contrast. And so I think that's because when we are exporting out the color, we're using a 2.2 gamma. And if we drop this down to 1, I think it should export out exactly as we see it. So let's re-export this. Yeah, that's a little bit better. Honestly, though, let's do a little bit more. And that's in the volume slice here, we can change the visualization range more. We can go to like 100, maybe, if we wanted to. Not going to though for this tutorial, I guess, just because it's not worth it. So anyways, we have, let's bake this out one last time. So then we can go back to our image context, our flipbook, and instead of loading in the color, let's go to a composite view again, and then frame 64. And instead of loading in our color, we can load in our density, and we just name this something else, like density, and hit render. And now we have our I don't know why this is called testing, but render testing. I mean, you can also just make a new thing and call it density and just render this. And now it will be called testing density. Cool, so there's our flipbook. Now if we go into Unreal and my messy project, we drop in the velocity and actually the density was the one that we made loop and everything, so let's use this one. And we just load it up into our shader that we have here, which is a big mess, but it's just a recreation of that shader bits link that I was showing you at the beginning. It's a recreation of this to sample the texture. And like our frame size is 2048 for our total flipbook size. Our edge texels is 4 because there's 2 on each side, and then frames is 8 by 8. So we just sample that. Where's our density that we just made? And then all of this gross math is just like scaling and offsetting the output noise so that we get more contrast out of it. So yeah, there's our swirly noise. If I just plug in this output directly to the base color so we can just see the raw data, it is very white. So I mean, like, yeah, this is all that I'm really doing here, and instead I'm just like subtracting 0.5 to kind of like offset it down a little bit and make it darker. Like add the contrast to it. And yeah, so you can see that there are seams there, but if we open up our texture that we imported and we go map settings, go to no maps, and then hit save, voila, those weird texture seams are mostly gone, especially from a distance. And so the only thing there now, I think, is just from the way that we exported the texture. Not enough particles, and it's kind of sampling weird. And like you can play with these values a little bit and it might help. Still need to do a little bit of work on making this like perfect. But if you change the edge texel size, you might be able to get something a little bit better. Yeah, like if I go down to 2, looks like they just about disappear. Yeah, so that's even better. There's still a little bit of a seam. And I think that's just because, well, I'm not sure. But yeah, looks pretty good. Looks very swoopy and swirly, and anyways, it has been an hour and 2 minutes, so that's where I stop. Hope that was interesting and not too terribly difficult to follow. It was mostly just a reference for me in the future when I need to relook at this again and I don't know what I'm doing. So